Okay, we're going to continue with some more examples. The chain rule is kind of a straightforward rule, but you really do have to practice it like a lot. You just have to practice all kinds of different problems that involve the chain rule. So there are two more problems on this page, cosine of x to the fourth and tan squared of x. I am going to have you try these on your own first, but I think it might be helpful to think of tan squared x as tangent x squared, right? So that might help you identify the inside and the outside functions. So go ahead and pause the video for a minute. And using the same technique that we used in the first two examples in the first video, see what you can make of taking the derivative of these two functions using the chain rule. Okay, so I have identified, I'll start with number 3. The inside function is x to the fourth, that's my u, and my outside function is the cosine of u. So when I take the derivative, I start with the derivative of the outside. So the derivative of cosine u is negative sine u. So negative sine, and then I input my u, which is my inside function. So derivative of the outside, leaving the inside alone, and then we multiply by the derivative of the inside. So eventually you're going to get to the point where you're going to look at this and you're going to say, okay, my derivative will be negative sine. You'll leave that inside alone, and then you'll just kick out the derivative of that inside, and you won't necessarily write it in these pieces. You'll be able to do it kind of in one string in your head, but it takes some time and some practice. So for number 4, the inside function is now the tangent. And what are we doing to that inside function? We're squaring it. So the derivative of u squared is 2u. Fill in what my u is, and then I multiply by the derivative of that u. So we're just going to kind of keep going with some more examples and continue to build a little bit more into each set of examples that we're doing. So again, we're going to take 5 and 6 as our next two to try. I strongly advise you to rewrite number 5 like this first. If you've got that denominator it as like something squared, rewriting it as something to the -2 makes it easier for you to use the chain rule. It is true you could use the quotient rule on number 5, but I think it's going to be a lot easier to use the chain rule. I usually only use the quotient rule when I have to. And if I can rewrite this like this and then think about the chain rule, that's going to be a lot quicker and faster. So give this one a try. And then also we're going to be giving you a moment to try number 6. Now you'll see here I have an inside function to the third power. So my outside is definitely going to be u to the third. And my inside function is a quotient. And there's nothing I can do about it. I'm going to have to use the quotient rule when I go to do the derivative of the inside function for number 6. So go ahead and press pause, give these two a try, and come back. Okay, here we go. So if I've rewritten my function this way, then my inside is going to be the 3t plus 7, the part that's raised to this power, and my outside will be 12 u to the -2. So I'm going to take the derivative of that. That would give me a -24 u to the -3. Keep my u, my inside the same, and then multiply by the derivative of 3t plus 7, which is just 3. So I'm just going to multiply together my constants and kick my exponent, negative exponent, down to the denominator. Trust me, that was a lot easier than trying to apply the product rule. Not the product rule, the quotient rule. Okay, number 6. So we mentioned this. My outside is going to be u to the third, and my inside is this quotient. So the derivative of the outside would be 3u squared, 3u squared. And then I need the quotient rule to take the derivative here. So low d high minus high d low over low low. I just did a real quick calculation of multiplying that out. I saw that the two x's are going to cancel and I'll be left with just 11 on the top over the 2x plus 1 squared. Oh, I just noticed I did something incorrectly here. I was trying to rewrite this as the top squared over the bottom squared, but I failed to square the bottom. So that means when I multiply these together, I'll have 2x to the fourth, not the third. And then I just combine my coefficients on the top. So the chain rule is basically one of those things that comes into play whenever we have a derivative that involves a composite function. If there's a function inside another, we have to apply the chain rule. So it could end up being involved in situations where I also am dealing with a quotient rule, or perhaps a product rule. It's just, it can be used in any type of derivative in combination with any of the other types of rules. So since we're kind of doing these 2 by 2, I've got 2 more here. Okay. So I want you to try number 7 and number 8. And before you start, I just again want to mention something about number 8. It looks to me like we have a product. We have an e to a power times a cosine. So you're going to need a product rule to find the derivative of this function. Each individual function is going to require the chain rule because you have an inside, which will be the exponent on the e to the x, and an inside, which is the 3x inside the cosine. So start with your product rule, but then as you do the derivative of each individual function in the product rule, you'll need to use the chain rule. Give it a try. And I really hope that you do pause the video and try these because it makes a huge difference in your learning process to actually try it and make a mistake and learn from that mistake than to just copy it all down and say, okay, yeah, that makes sense. Because that's not what you're being tested on when you come to class. Does this make sense? Check yes or no. That's not the question, is it? The question is, can you do this? So try. All right, here we go. Number 7, pretty straightforward. I have e to a power as my outside and the power is the inside. That's a very common chain rule situation when you have e to a power and that power is not just x. This is going to be a scenario you'll see a lot. So the derivative of my outside is just e to that power, and then I multiply by the derivative of the power. A little bit of quick cleanup there. Okay, so here comes number 8. And as I was mentioning, I'm going to start off by doing the product rule. So in this first line, if you just look at the parts that I have written in the black, I have 2 things I'm adding for the product rule. So I take the first function, I don't change it, and then I need to multiply by the derivative of the second function. So we'll go through this in just a second. This is all the derivative of cosine of 3x using this information here. And I'm going to add the second function, don't do anything to it, times the derivative of the first function. So this part is all the derivative of e to the negative 5x. So let's just go ahead and look at those 2 derivatives. For cosine of 3x, my inside is 3x, my outside is cosine. So the derivative of the outside is negative sine, keep the inside the same, and then multiply by the derivative of the inside. For e to the negative 5x, it's just like what we did in number 7. It's e to a power. So the inside is the power, the outside is e to that power. Its derivative will be e to that power times the derivative of the power. So everything else I'm doing here is just kind of cleaning it up. In this step, I just multiplied things together in each term. Then I noticed that I have a negative e to the negative 5x in both terms, so I factored that out, which allows me to kick the e to the positive 5x down to the bottom, and I just left this negative in front of the whole thing. Okay, I think there's one more example here. that we'll do before we move on to using the chain rule more than once. So I'm just going to go ahead and walk through this one. You'll notice that I, once again, do have a product, but this time my product is in the exponent. So I immediately am going to be starting with the chain rule because I have e to a power. So my inside is x cosine x, and my outside is e to the u. So my whole function is this composite, e to the u. That's where I'm going to start with the chain rule. So my derivative is e to the u. And I will fill in what that u is. And then now I need to multiply by the derivative of the u of the inside. And here's where a product rule is going to come in. I don't have any more composites. I just have a straight product rule. First function times the derivative of the second function plus the second function times the derivative of the first. I don't know that there's really a whole lot that can be done with that, so I'll probably just rewrite that inside as cosine x minus x sine x and leave it at that. Do you want to just point out the difference? Because I get this question a lot. How do I know whether I should start with the chain rule or start with the product rule? And it just depends on the function you have. So like I said, this entire function is e to a power. There is no product in the outside function, right? E to a power. So I immediately start off by using the chain rule. It isn't until I get to the inside derivative that the product rule arises. That's different than the one we did here in number 8, because this function started off as a product. I have e to something times cosine of something. So I immediately need to start by using the product rule because my original function is a product. And then within each term of the product rule, I ended up having a composite function that needed the chain rule. So again, the more practice you get with these, the more used to that you get, the more kind of intuitive those things become. And the better you are at kind of seeing what needs to come first.